Mansur is with us from Kazan Federal University, and so the virtual stage is yours. Please take the stage.
Thank you for the introduction. Thank you for opportunity to speak here. I have defended my PhD at the Kazan Federal University, but today I will tell you my talk is not related to my research at all. I will tell you about QJudge. It is an open source tool to automate testing of solutions that are quantum circuits. So I will start with trying to convince you that this tool is necessary. Then I will dive into implementation details, into future plans, and finally, if time permits, I will show you some demonstration of this tool, of this platform. So, why do we need to automate testing? I was in a jury of several quantum technologies competitions. I was evaluating solutions in quantum algorithms, but most of the participants had a background in physics. So this task had to be easy tasks, something about circuits. Sometimes maybe they didn't know quantum programming languages and so on. And this testing of these solutions has to be automated. Because this competition had to be fast, so we do not spend much time testing. And another reason for developing this tool was that I had to teach a course on quantum algorithms. It was introductory course. It was something like 10 students in their final year. And I also wanted to give them quick feedback. And because it was introductory, they had no knowledge of quantum programming languages or libraries. And I started from the beginning. So I had to tell about circuits and so on, circuit model. And I wanted to give some tasks about this circuit model and to test them. So to sum up, we need automated testing because and when there is no knowledge of no knowledge of quantum programming libraries or languages, probably your students are not programmers at all, or they know some other programming languages like C++, C, C++, or Java. Maybe they know different languages. And you want to give quick feedback. So you do not want to spend like a day checking all these solutions, and you want to give this feedback as fast as possible. So what are testing systems? There are a lot of testing platforms. Some are open source, some are not, like QJudge, Codeforces. They are used in programming competitions, in hiring candidates for programming positions. And usually they have some sort of list of problems or something like that. And you write a program, you submit it, system compiles it, and then it feeds predefined input to this solution. So then it checks if the program gives correct output, and then repeat it several times for all predefined inputs. The problem here is that you can't use circuit as solution, and even if you have some open source solution like QJudge or something like that, it is not easy to plug this to plug the part that makes possible to use circuit as solution. So now I will show just some screenshots, and I will show demonstration at the end, but if I had no time, so this is some replacement. So this is a list of problems, and you have something like that. You have a problem description, and you can just drag and drop gates to make a circuit, and then submit it and see where it is right or wrong and what errors are. Now to the implementation. Front end that I showed you on the screenshots talks to backend, okay. And I wanted to make this solution scalable. So the most time-consuming part is checking the solution, starting up this quantum simulator. So I divided this server into server part that serves web pages and worker part that really checks the solution, and you can start as many workers as you like. They all use single queue and single database to store problems, tests, and results, broadly speaking. So frontend uses a fork of Quirk to show this interface for dragging and dropping gates. But in this fork, I removed gates that are not supported, like post selection, gates that are time dependent, some kind of non-physical gates, and so on. And frontend sends JSON to backend, which imports to Circ, a quantum library developed by Google. And because we use JSON as a program, as this quantum program, there is no need to jail solution. So we don't need to use containers or something like that. And then, of course, it runs these circuits, it feeds it inputs to it. So, for example, this kind of circuit converted into this kind of JSON, and then it is compiled into Circ object. So what kind of predefined tests are possible? Simplest one is when you want the circuit to convert one base state to another base state. Like, for example, we want to, so student comes up with a circuit that converts 001 state into 010 state and so on, something like that. For example, it is possible that some kind of oracle needs to be developed. So here we have base state, and here we also have base state. And it is described like this. So you have some JSON object that describes your input, your output, and you have a lot of this kind of tests. You can also allow usage of ancilla qubits. So for example, you can permit a solution that gives some kind of the state with alpha 0 and alpha 1, some numbers, but it is okay as long as the first 3 qubits are in state 010. So it is another type of test, and it is described as this one. Of course, you can describe test where you define all amplitudes. For example, you say that base state 000 should be mapped into state with amplitudes alpha 0 for 000, alpha 1 for 001, and so on. For example, it can be some kind of phase oracle, some single operations, like you ask students to find what unitary gives these amplitudes and so on. And output is described in such way. You simply write all the amplitudes you have, and each amplitude is a complex number, and it is encoded as a pair of numbers. And all these amplitudes are compared with up to some precision epsilon. Of course, you can, it is boring to write all these amplitudes, so you can, there is another type of test where you can simply ask for some specific amplitudes of some specific states. And finally, the most interesting test is where you ask for probability of some result of measurement. For example, you ask for a state that has an odd number of bits set. So for example, you ask for a circuit that will give these states and total probability is larger than 3/4. And for example, you can ask to develop algorithm, to solve some task, real task, and so you want to measure your result. And this is, of course, described in the same way with some JSON object where you list all states and say how these probabilities are, what probabilities should there be. You can also use oracles in your tests. So it is a special gate that are used in the solution. So it's some kind of way to input, to define a function from the real world, some input that your algorithm has to use. Tests can define different oracles, for example, function, balanced function, or constant function, and so on. And solution and tests define these oracles in some way, simply as a circuit that I showed you before in the same language, same protocol is for oracles. And you can easily extend this checking environment. You can write another Python script and get your test from standard input, send it to circuit, and then measure something, or I don't know, take an amplitude of something and then write whether this test was right or wrong for this particular input. So this work is an early stage, this software. So I want to add some kind of user interface for teacher, at least more comfortable user interface where you can like filter solutions by students, by results, see them, test them without going into SQL command line interface, like something with buttons. Another user interface for designing problems, like writing these tests without JSON, like putting some gates onto circuit and so on. This software does not have even automatic registration where you can type your email and get an account. I have to manually register all users. Well, it was okay because I had only 10 students. But if there is an interest in my software, I can add more automation to it. More user-friendly error messages for users so they can better understand what's going on, and some kind of system administration tools and some kind of hosted instance so everyone can join and solve some quantum programming competitions with circuits. And of course, I want to test it more. So if you're interested in this solution, please write me. I will be glad to more users of this software, so I can understand what other users need. And finally, I have some time, so I will switch to short demonstration. So here, I hope you see my browser, and this is a list of solutions. It's the list of problems that I have. So this problem is not solved at all. I tried to solve it, but there was no solution. This is partly solved, so my solution worked, but not for all tests that were defined. And finally, these ones are solved. Let's see this problem that is not solved. So I have description of the problem. Basically, well, you can read it, but basically it is it requires to write Deutsch-Jose algorithm, but with some difference in the end. So this is Oracle I told you about. In the test, it will be different kind of circuit. Here it is simply a sum of all bits. And in the odd test, it will be another circuit. So, okay, I will not tell you how this is solved, and you can, I send it to server, and I can now, okay. And you can see that this solution is now shown in the table. Well, that's all. Thank you for listening. You can find all this software in repository. I will share all the links in Discord channel. You can try it here, but you have to ask me for account because I have to put into a database your account. So thank you again. And if you have some questions, I will be glad to answer them.
Thank you, Mansur, for the talk and for this great tool. So, any questions? I know it has been a long session, but we still have 9 minutes until concluding the session, so we have enough time for several questions. So one question is, how long did it take you to develop this tool?
Well, actually, it was like a couple of months, probably, because it's very early alpha stage. So actually, it is not very much of my development, and a lot has been done before. It's open source, and I use open source libraries inside. So it was a month or two to develop it to this stage.
So this is from me as a follow-up question for do you think that there can be any additional modules that can be added to your work?
Yes, I think it can be improved. You can add something more, but well, one reason to give a talk about it was to ask whether to ask if you have any interest in this work. Probably you have some ideas how this what can be done, what can be added to this software, because you know, it is more interesting to like share work than just do it for myself. And so my work would be used, would have more users than just me.